So when we take the derivative of this, we're taking the derivative with respect to x. But because we cannot solve for y, we're going to have to take the derivative of the y's as well. However, you're still taking the derivative with respect to x. And so it kind of behaves differently. You're going to, okay, I'm going to write it out like this. I'm going to take the derivative with respect to x. And so what's that going to look like? Let's write it out long ways. We're going to have d over dx. We're going to take the derivative of y to the fourth power. And then we're going to take the derivative of the next term, which is x times y. And then we're going to take the derivative of the next term, which is x to the third. And then the next one, which is just x. And then the next one, which is 2. Now the ones that are x's, you guys know how to do already. But the ones that are y's, something different has to happen. So here we go. Let's do the right side first because you guys know that side. That's 3x squared minus 1. Okay, and then you take the derivative of a constant that's just 0. Okay, so what about the left side? What do we do with that? Well, for the y's, you treat it kind of like the x, where you do the same thing. You drop the 4 and then you subtract 1. Okay, but because y, you got to think of y as like there's x's inside of y, because the y is a function of the x. I don't know, that's kind of weird to say, but you're going to multiply this by, you can write y prime or you can write dy over dx, which I like writing better, but you can write it how you want. So you're multiplying it by dy over dx. And then this one right here, the next one, this guy, we're going to have to do the product rule. So it looks like I don't have enough space right there, so I'm going to move this guy out a little bit. Okay, now I have space. All right, now because I have two variables multiplying to each other in here, I'm going to have to use the product rule to find the derivative of these guys. So what we do first is take the derivative of the first one, so that's going to be 1, right? And then we have to multiply that times y. And we're going to add, now we're going to take the derivative of the second one. This time it's, the derivative of y would be 1, and what do we have to multiply it by? dy over dx. And then we multiply it by the x. Okay, so you guys got that? Let me pause it. I don't know if this is going to help anybody, but if you have, it definitely helped one student. If you have a y, you're taking the derivative of this. It's y to the 1 power, right? You drop the 1, and you subtract 1 from the 1, you know, for the derivative. So you have 1 times y raised to the 1 minus 1, which is 0. And what is y to the 0? It's just 1. And so that's why we have a 1 right there, and then we're multiplying it by dy over dx, or y prime. So we finished taking the derivative, but we still need to know. We need to know what is dy over dx, because that's our end goal. Our end goal is to know, okay, dy over dx, what is this answer? Because that would be our derivative function. In order to find this, what we're going to do is we're going to get all the dy over dx terms on the same side, and then factor out the dy over dx. So this is a dy over dx term. This is a dy over dx term. And so I need this guy to go over here. Okay, so I'm going to move that guy over there. And let's see what we get. We have 4y to the third times dy over dx plus, that's going to be x times dy over dx equals, and we have 3x to the second power minus 1 minus y. Okay, so I just took this guy, moved him over here. That's why he's right there. Okay, and then now I'm going to take this, and I'm going to factor out a dy over dx from this term and from that term. So now it says dy over dx multiplied to 4y to the third plus x equals 3x squared minus 1 minus y. And so how am I going to get dy over dx alone now? Yeah, just divide it. So now it's 3 times x squared minus 1 minus y divided by 4y to the third plus x. And this is your slope function. This is, right, this is y prime or f prime. This is the slope function. So what does this want us to do? It wants us to find an equation of a tangent line, right? So what we need is a point. We need a point to plug into this. What point are we using? We're using this one, 1, 1. Oh, I love ones. Okay, so let's plug in all the 1s to that. So it's going to be 3 1 squared minus 1 minus 1. On the bottom we have 4 times 1 to the third plus 1. What does it simplify to? On the top I get 3 minus 2. On the bottom I get 4 plus 1, so I get 1 over 5. So this is our slope. Yeah, well, it's actually for this line right here. Does that look like 1 over 5? Yeah, it does. So now what we got? Y minus y1. Y1 is this y right here, so I put a 1 right there, equals my slope times x minus x1, and my x1 is that point right there, so it's 1. You can write this in slope-intercept form if you want, but point-slope form is fine with me. So there's the equation.